As an actor, I'm really interested in and spend a lot of time studying human beings, human nature, human behavior, even the human body. And when I look at the world around me, I wonder, what is this technology we have? What are we doing with it? What is it doing to us? Is it changing us? Where is humanity heading with this stuff? As our technology's gotten more and more sophisticated, it seems like it's come to dominate every part of our lives. About the only place it has yet to fully invade is our actual bodies. But maybe that's all about to change. I'm told that there are scientists out there developing cyborgs. A cyborg is a kind of hybrid of man and machine. It's supposed to be an enhanced human being, a better, stronger, improved version of us, more than human. Now, when I was asked to participate in a documentary about cyborgs, I was intrigued. I couldn't say no. It's very cool stuff, but it also scares me. I confess, at bottom, I have a pessimistic dystopian view of this kind of thing. Won't it completely dehumanize us? This view was shaped by all the science fiction I read growing up. I read a lot of it. I still read it. So, I'm visiting my local science fiction bookstore to do some research. Well, okay, that's a little tongue-in-cheek. I'm not a total dummy, but there's a little science in science fiction, and why not start with what you know, when you're about to find out a whole lot about what you don't know. C.C. James, the owner of the bookstore, helped me in my search for books on cyborgs.
By the 23rd century, humans are extinct, but they're self-aware. Robots carry on, building a vast civilization designed as an empathetic sex slave. Human-sized Freya is a free woman, but that doesn't stop her smaller, high-ranking cousins.
This sounds great.
It's actually really good.
Is it? Okay. Is this guy good?
There's a lot of sex. He's great. And this is actually based on a book by Robert Heinlein called Friday, about kind of like a semi-cyborg sex assassin.
Yeah, wait a minute, that's one.
That's great.
Cyborg sex assassin.
Yes, exactly.
That's what we should retitle. That's what we should retitle the show. In fact, that's going to be my memoir title. That's my new. Oh, is it?
There are things that early adopter body modification people are interested in, where they're actually implanting.
What? Wait, early adapter body modification people?
Yes.
So these are people who have like, I'm going to put like a.
They're doing weird things to themselves.
Have horns
right
and stuff
now.
like that.
Like that, but they're actually. They're people who are putting magnets in the tips of their fingers so that they can feel electromagnetic fields around them. Or
for the purposes of like extrasensory perception.
Exactly.
It always seems so easy and seamless making cyborgs in science fiction books. You just add metal arms and metal legs and infrared eyes and voila. But all this stuff is really quite challenging in reality. The idea of trying to find mechanical ways to enhance ourselves is nothing new. This film I came across from the 1960s shows one idea that was way ahead of its time.
The story of science, changing man's way of life in our time. At the General Electric Company's Research and Development Center near Schenectady, New York, where anything that man or child might imagine is not considered impossible, one may witness a scientific endeavor to convert a man's legs into those of a giant. Inside this mechanical skeleton, a human being endows it with the intelligence of his own brain.
The exoskeleton in this GE film may have given us a look into the future. I heard about a new device that sounds just like it. So I flew down to Perry, Georgia to see it in action. It all went down at a place called the Guardian Center, a huge installation where they train first responders for earthquakes, terrorist situations. They even have their own subway tunnel with an exploded train. It's the perfect place to see the Fortis Exoskeleton. Designed by a team of engineers at Lockheed Martin, Fortis is an aluminum and carbon fiber frame exoskeleton with 2 mechanical arms designed to give tools a zero-gravity, weightless feel. It lets workers in a variety of industries wield heavy tools for hours on end. The lady wielding this tool is Trish Elker. She's the head of the Fortis design team.
It's very lightweight, it's very easy to put on, it's very adjustable to adjust from piece body type to my body size.
Right, so it's one size will generally fit all.
After the Guardian guys get our test vehicle positioned, they'll deliver a tailor-made emergency situation.
Very exciting. Have we taken bets on what's going to get destroyed besides the car?
Here we go.
Oh.
This will be the first time the Fortis is being used in a first responder situation. It's also the first time it's being used with the jaws of life, a 35-pound tool used to pry open the doors of crashed cars.
Awesome. Holy cow. Awesome. Nicely done, Kate.
That's how they work.
It may look simple, but making an exoskeleton that's a help and not a hindrance is a deceptively difficult engineering task. That it's designed to adjust and fit any sized person only makes it more so.
Anthropometry is the measurements of the human body. Everybody's anthropometry is different. Your knee may be higher or shorter than mine. You know, your thigh is longer or shorter.
Everything's going to be unique.
No two people are the same. And so that's why the system has to be so adjustable. It has to be able to accommodate all those different anthropometries.
I guess creating an interface between man and machine is what cyborgs are all about. And I'm beginning to understand that it may be the hardest problem in turning us into next-generation humans. I heard about a somewhat different exoskeleton in Sao Paulo, Brazil, that not only interfaces with the body, but also with the user's brain. Now, that sounds like something I need to see. I'm on my way to meet a brilliant gentleman, neuroscientist Miguel Nicolelis. In an experiment with a rhesus monkey named Aurora, Miguel created one of the earliest direct interfaces between a machine and a brain.
Aurora was playing a game with a joystick, and she had to move a cursor on a computer screen to put that cursor inside of a target to get a drop of juice, fruit juice.
It's like being an actor, by the way. It sounds a lot like...
It is. She was doing this, and we were recording the brain activity. We started in 2 dimensions, and then we did 3D. And we saw that we could read the electrical patterns, sent to the models, and the output in digital form could be sent to the robotic arm that was in another room, and the robotic arm was reproducing the movements that Aurora was making.
Miguel discovered how to read the motor commands from a monkey's brain and have them control the movement of a robotic arm. This was one of the first brain-machine interfaces. The experiment got even more amazing when Miguel took the joystick away from the monkey.
To get the cursor to move to the target, she had to imagine the movements, but not perform them, because she had no joystick.
Did she want to keep doing that?
Oh, in the beginning she tried.
Right.
She tried, but there was nothing there. And being a smart monkey, she realized, what in heavens I'm doing? Why I'm moving? There's no connection, there's no causal linkage.
Yeah.
So she stopped moving. In front of us, she just did this. She stopped moving, and the cursor started going.
She knew enough to guide it now just visually.
By trial and error, she realized that there was no point in wasting energy moving her own body. She had a much better way to get the juice. That was the first time that the brain had crossed the physical limits of the body to act on the world beyond the body by itself.
So this kind of stuff leads to the exoskeleton that you build.
It was at that moment that we realized that it could be done.
Heading an international team of over 150 scientists, engineers, and medical doctors, Miguel is developing an amazing exoskeleton that the user can control just using thoughts. The brain-machine interface works through a non-invasive EEG skull cap.
When the patients start using the exo, we notice that in the beginning it's very difficult. because they have lost the representation of their legs. So when I asked them, think about walking, they said, okay, I'm trying, but we look at their brain activity, you see nothing.
Right,
because after 13 years without moving, your brain has forgotten that you one day had legs. You dream about it, you may have feelings about it, but the representation of your legs in your brain has shrunk.
Suleiman Shakur, a senior research scientist at Miguel's lab, designed an ingenious virtual reality feedback system to help restore the experience of walking to the patient's brains.
They're a very simple, actually, system. They are simple vibrators, the same way that you have in your cell phone.
Okay.
And there's a trick that we can play by changing the frequency of these vibrators. That at some point you will not feel 3 vibrators anymore, but you feel 1 continuous touch.
The vibrators he straps on my arms produce a sensation that are synchronized with the legs and footsteps of a virtual soccer player. When Suleiman starts up the program, I start to feel the vibrators on my arm synchronized with each step of the avatar.
Definitely gives me this sense of forward motion. Each step, it's a move forward.
Miguel figured out a way to incorporate a similar feedback system into the exosuit itself. When the robotic suit starts to move and touches the ground, signals are transmitted from sensors on the feet to an electronic vibration device on the patient's arm.
15 years ago, when we discovered that this could be done theoretically, we said, okay, brain-machine interfaces will provide a new rehab tool to make you walk again, move your arms again, and that's it. Well, what we realize now in all our patients is that there's a plateau above that. And that is, they're recovering neurological function by doing that.
You're kidding me.
Just by practicing.
So it's like it's literally regrowing those areas of the brain.
The plasticity that we're inducing in the brain somehow is getting down, and the patients are now contracting groups of muscles below the level of the lesion to a point that one of them is actually moving the legs voluntarily now.
This is Eric Vlatkovic, a former soccer player who many years ago lost the use of his legs in an accident. Eric is the first paraplegic to walk again with the help of the exosuit.
When he imagined starting walking, he modulated his EEG signal. The machine detected that and triggered the movement.
That's amazing.
And then when the feedback came, he had the feeling.
You could feel it.
Feedback.
Feedback.
Feedback
awesome.
foi muito importante, né? When your sense of self expands to incorporate a device like this, that has feedback and everything, you're actually changing what the brain thinks is the body. That's number one. You're actually helping the patient to gain mobility, but you're changing, you're reorganizing the connectivity.
It's the ultimate cybernetic thing. In some degree, that you're
creating a hybrid. I came back to biking late in life. In the beginning, it was kind of strange, but in a few weeks, I felt that feeling that you feel as a kid. You know, the bike is part of you. Now, what is your body at that point? Where it ends. For me, at that point, my body ends at the surface of the tire touching the ground.
So our brain incorporates the tools and technologies we use every day, the things we ride on, the tools we work with. All of the technology we use is almost literally an extension of us.
So I have a very different concept of cyborg or hybrids or transhuman movement. We, of course, need to embrace technology like we embrace art because it comes from our brain. It's a manifestation of the inner works of our imagination, of our biology. Yet, I don't want to reduce the human condition to a piece of machinery, because it's not. What would be of our existence if we remove all that is abstraction, intuition, and creativity and leave only the devices we built?
Really is.
You know, when I was a kid, here in São Paulo, 9 years old, Neil Armstrong lands in the moon. I'm watching this in the black and white TV in the middle of nowhere, and I said, that's what I want to do in my life. I knew at that second I wanted to be a scientist because this guy had gone to the moon. And he was not just a guy, Neil Armstrong, it was the whole species. So people 50, 55 my age, if you ask them when you became a scientist, a great deal was because of
you
the
were
Apollo.
At the perfect age.
Yeah. Fast forward 50 years ago, I take my kids to the movies and they look at me and said, don't say you're a scientist. I said, why? He said, because scientists are bad guys, they're villains. So look at the movie we're about to watch. I said, what are you talking about? And it's true.
You're all psychopaths.
We are psychopaths, we want to dominate the planet, we want to kill Iron Man, we want to go after Batman. Why? It's not true.
On my way out of Brazil, I was really thinking about my brain. This idea that the brain incorporates the technologies we use and makes them a part of us is fascinating. If it's true, then what's the difference between a person holding a hammer and a person with a hammer hand? That Miguel has figured out how to hardwire machines directly to our brains is amazing. With that figured out, creating a man-machine seems utterly plausible. So it excited me to learn about a scientist in Houston, Texas, who's working on a different way to connect our brains to technology. I'm walking down this endless corridor at Baylor College of Medicine to eventually meet up with David Eagleman. David is a neuroscientist noted for his work on time perception, synesthesia, and neurolaw.
For a long time, I've been thinking about how flexible the brain is and how it takes in these different sensory streams and figures out just what to do with them. And when I started looking across the animal kingdom, I thought, there are really different sensors that get popped onto different animals. Like the star-nosed mole has this nose with 22 little appendages, and it feels around and sort of makes, in these dark tunnels, it sort of makes a 3D view of its
they're
world.
like fingers on its face.
So the more and more I looked across the animal kingdom, I thought, what if all these things are really just plug-and-play devices, and Mother Nature just had to come up with the principles of brain operation once, and then she was free to tinker around with what you plug in. So I've called this the potato head theory. And the idea is you can just plug stuff in, just like the child's toy. You plug in whatever you want, and the brain will figure out what to do with it. So I started taking that idea really seriously, and I thought, what could we start plugging in to the brain? And that's the origin of this VEST that we came up with. The VEST stands for the Variable Extrasensory Transducer. And it's a VEST.
Works out perfectly. Perfect. It never happens like that with acronyms. Okay. Yes.
So you wear it underneath the clothing, and what we do is capture information on a cell phone, and we transmit via Bluetooth to the vest. We've got this remarkable sensory sheet that we're covered with. Your skin is the largest organ in your body, and we can feed any kind of information stream to the brain this way. So it's like an adapter between the human brain and whatever we want to feed in.
A smartphone converts sound to data and then transfers it to the vest via Bluetooth. 40 little motors vibrate patterns into the wearer's back, creating a kind of soundtrack of the immediate surroundings. With training, it allows the deaf person to feel sound, similar to the way that Braille converts the visual code of written text into a code of tactile sensation. David is developing the vest with one of his PhD students, Scott Novich. When Scott conducts a training session with Jonathan Leach, I get to really see the vest in action. Jonathan has been profoundly deaf since birth.
Right. Right. 2. 2. 2. Ear. Ear. Touch.
It's almost like a localized area massage.
That's nice. And it's kind of moving up and down the spine.
Well, it's like you have 10 phones on your back, all located around the back, and you could feel the phone ringing. All the phones were ringing at the same time.
Oh, really?
I can hear everything. Whatever is going into that tablet, that microphone, it's getting. If someone drops something or if something's happening out in the environment, I can feel it.
So what happens now?
Well, now we can turn it on. So.
Whoa. It's strong.
It's pretty strong.
What's it registering off of? Are you just like kind of or is it me speaking?
It's you speaking.
Oh, that's me talking that's doing this.
Yep. Yep. So, I mean, the way this generally works is sound is being picked up from the environment by the tablet's microphone. The tablet's actually taking care of all of the mathematical computation to get the signal into sort of a suitable shape such that that information will get through your touch receptors in your back.
I thought it was going to be less kind of intense. Wow, that's wild.
If you have two people come up to you and say the same word, like cat,
Yeah.
it will feel very similar, but it will still be distinctly different.
It's a bit more that global sense rather than the thing you were talking about before.
Yeah, so
it's kind of
the
that
idea
you're
is you're
getting
kind of
more of the
getting kind of
gestalt of the word.
That's
use
a great
gestalt?
I think so. You'll have to run that one by David, but I think you got it.
But I mean, you're getting more the kind of that round sense of the thing rather than these kind of, and you can feel that actually. It doesn't feel like Morse code. It didn't feel like the same thing every time.
This way, we're starting by feeding in sound information that we capture on the fly, compress, send to the vest so that people can hear the world through patterns of vibration on their torso. But that's just step one. That's sensory substitution. But what really interests me is sensory addition.
David is thinking of feeding all sorts of real-time information through the vest and into our brains. Things like stock market data and weather data.
One thing we've done, just as a proof of principle, is instead of the Spidey sense, I call it the Tweety Sense, which is we collect thousands of tweets on some particular hashtag and then feed into the vest a sentiment analysis, meaning we're just doing quick language processing on it to decide whether people are saying positive or negative things about it. And you can just walk around and feel how that's going.
Oh man! Now I question whether this is going to be a pleasant experience for people.
Well, the thing is, it probably wouldn't be for almost anybody, except for you can imagine if you were, let's say, a presidential candidate doing a live speech. You might want to know how things are going over, and Twitter is giving you that feedback immediately, so you're plugged into the consciousness of thousands of people, maybe hundreds of thousands of people all at once hearing your speech, and you can say, oh, that didn't go over so well.
Holy cow.
You're feeling the Twitter sphere.
You must have to deal with a lot of people saying, but hang on, this is like crazy. You know, you're going to make us not human anymore. We don't need to be doing this. Isn't it already bad enough with all the stuff we're getting through our phones? Aren't we robotic? Aren't we cyborged enough?
Well, let's define what we mean by human. I mean, what would it mean to be human?
In the first place.
So we're already way past that, right? I mean, we are no longer a natural species, and we are, we're a species that's in this feedback loop. We're a runaway brain. You know, we're on a trajectory. Actually, let me take that statement back. Let me cast it a different way.
Oh, yeah.
It's that this is our evolutionary trajectory. This is all part of what's happening.
Yeah.
And so what it means to be human is a rapidly changing definition.
So there's the sense that it's not even just has to happen, it's just going to happen.
Exactly.
Yeah, and so
it's what's happening.
It is what's happening.
Yeah.
I wonder if our attachment to technology is hardwired into us in some way. Are we just bound to turn ourselves into machines? Wow, maybe we aren't turning ourselves into machines. Maybe we already are machines. And if that's true, then all these technological gadgets we produce are simply our offspring. Heading for the airport, I can't stop thinking about the plasticity of our brains. If they really are nothing more than a piece of electric meat in a black box, then replacing our entire body with plastic and metal parts shouldn't really change our nature, right? But what about the body? The particular physical form we're born with? Doesn't it have something to do with who we are as human beings? To better understand the mind-body relationship, I'm visiting Stockholm, Sweden. I'm very excited to soon meet an imaginative young neuroscientist named Henrik Ersson at the Karolinska Institute. Henrik is trying to understand how the brain decides where our bodies end and where the rest of the world begins. His research is leading to new and improved ways to extend ourselves with technology.
Well, there's a lot of interest in the robotics community. How can we extend the human body? Not only with advanced prosthetic limbs for amputees, but maybe for exoskeletons. And then, of course, the question is, at what point do these external devices become part of your own body representation? At what point do you start to feel that this is really me?
Sitting in the lab with Henrik and Andreas, one of Henrik's postdocs, I'm about to be put through the rubber hand experiment.
And then put your arm here onto the table and inside this little box here. Cover your right side here. Okay. So what I will do now, I will touch your index finger with the brush here, and please look to the index finger of the hand here.
Okay. With my hand hidden from view, Andreas starts to stroke my index finger and the index finger of the rubber hand in almost perfect synchrony.
What do you experience?
I think it is genuinely beginning to become hard to tell whether, I mean, it's beginning to feel like, yeah, I'm buying it, that you're rubbing, that you're swiping that hand. Part of my brain is telling me that it's not possible that that's happening, you know? And then when you're not touching it, I go, no, not happening. And then you touch it. I'm like, yeah, I'm feeling it there. It's totally now just, it doesn't even, there's no question that that's my hand, that that's what you're touching.
All right. That's the first experiment.
That's crazy. That's super crazy.
And when they connect my finger with the rubber hand's finger and introduce movement to the experiment, well, now the illusion gets totally surreal.
Oh my God, that's crazy. That's really weird. Oh man, that's nuts. There was a real moment where it suddenly switched. I was like, no, this isn't working. And then suddenly, now it's just, again, the more I'm doing it.
But that's the thing, now I'm not doing anything, now you do it.
That's crazy. I'm doing this. That's crazy, and it only gets more so as it goes on.
You have a new hand. Artificial hand.
That's amazing.
You can touch it.
Wow, if they can add a rubber hand to my body that easily, I can only imagine what they could do with a little more effort and planning.
The idea of integrating into a prosthetic limb, what is going to give you that real sense of ownership of your arm? What kicks in then that does that?
Well, in your experiment, we stroked the finger.
Yeah.
And then you saw the model hand moving or being stroked in the same place at the same time.
Yeah.
And that was enough for the brain to sort of put together the visual information with the information from touch and proprioception, right?
Yeah.
And suddenly your brain just accepted the model hand as being my hand.
That was the most bizarre part of it, was where it felt like it joined. Literally, the muscles and nerves and tendons and everything were joined.
One of the findings is really how the perception of our body, our physical self, can change just like that in a few seconds. And really that it's really about how the brain interprets the information from the different sensory modalities and come up with sort of a decision or conclusion, which can be quite different from the actual physical state of your body.
After the hand experiment, I'm ushered back into Henrik's mad chamber of cyber psychology. There we do an even nuttier experiment, in which another suave European scientist named Bjorn straps me into a set of virtual reality goggles. The goggles give me the view of the body of a small doll lying on the bed next to me. Stroking me and the doll in a precisely synchronous way, the weirdness begins.
Oh, this is really odd. This is super weird.
What do you feel?
It's very peculiar. It's like, it's really being a child. It's like a baby. It's really strange.
Hello, how are you doing in that
Yeah,
role?
very good, very good.
You're meeting a giant.
Yeah.
Once I was in the doll's body, my perspective of the world changed. Suddenly everything seems bigger.
How's that?
It's about twice as big as...
Really?
Yeah.
My brain is really fooled into thinking I'm a small doll.
The knife looks huge. Oh! That was really disturbing. How small a doll have you used? I mean, how tiny can you do it and it still sort of works? I mean, is there a point at which it's just too small? You can't just use some...
We don't think so. As long as the body is proportional, we would predict that the illusion works very well.
Oh, that's interesting.
We tried with bodies that are like, 20 centimeters, 30 centimeters.
And it's worked.
It works
as long
well.
as it's proportional.
As long as the
So you
body's
can't have some
proportional.
crazy thing with crazy clown feet.
No.
That won't work.
That won't work. If,
Really?
if the body plan is completely different from a humanoid body shape, it will not
Oh, it won't
Yeah.
work. So
there's some memory representations, there's some constraints. The brain knows roughly what the human body should look like. It will not accept like a table or a block of wood or a crazy lobster.
It won't do that.
No,
so you can't put me into but you could put me into a bipedal thing? You couldn't put me in like ape legs.
Probably could put you in an ape. We haven't tried the ape, the orangutan.
Right, that could work.
Doing these experiments with Henrik really made me feel what I had learned intellectually with Miguel and David. The idea of fully inhabiting an exoskeleton or even the body of a computer-generated avatar feels much more possible to me now. When I got back from Sweden, my head was really spinning with all these new ideas. I needed to debrief for a second, maybe with a colleague, a buddy, not a scientist. So I told my friend, the director David Cronenberg, what I'd been doing. He was very excited and wanted to talk to me about this cyborg stuff. Well, I'm going to meet him at a local diner in Toronto for a coffee. In films like Videodrome, The Fly, and Existenz, he deeply explores the merging of man and machine. And not unlike the scientists I've been talking to, David has spent his career using his creativity and imagination to make new discoveries.
Okay, well, look, we're both wearing glasses, right? This is a machine-human interface. I got hearing aids. Look at this. This is a little computer. It has the computing power that's about 1,000 times more than what the first moonshot had, believe it or not.
Really?
Yes. Plus, my two hearing aids communicate through my head using Bluetooth. So, talk about machine-human interface. I'm there. I'm a bot. You know, like I'm bionic.
All of this stuff is just compensating. But all of this stuff is actually making us now extend beyond all.
Well, it is. I mean, I think the internet has made us already more than human. You know, I mean, I'm sure it has resulted in changes in the neurology of our brains, literally. I think the unique thing about some of the stuff I came up with was that it was organic. As in Existenz, for example, you have these game pods, but they're fleshy. They look like livers or something. And the cords are called umbicords, and they're umbilical, and they plug into your spine. That was my instinct, you know, that was where technology should take us, or would take us, in terms of how we interface our bodies with the external world.
They would become one thing.
Yeah, it would be organic, not mechanical. If you look at what's going on in our bodies all the time, constantly, it's little machines. Like they're little things with little propellers, and they're little tubules, and little things that are climbing up the tubules.
Snipping things.
And then they're snipping and repairing. So the kind of machinery that interests me in terms of enhancing us is really on the cellular level. We have a world of creatures that have evolved over millions of years. For example, I was thinking about the electric eel, where almost 2/3 of his body is a battery. We could have that because, you know, the earth, nature, evolution has already evolved that, has shown us that you can have a totally organic device that stores electrical energy and can release it on demand. There's a lot of sci-fi that said technology is inhuman, non-human, anti-human. And I always said, that can't be. It's totally human.
Right.
It comes from us.
It's us.
It's an expression of us. So it mirrors exactly what we are. That is to say, great stuff, brilliant stuff, beautiful stuff, and hideous, destructive stuff as well.
But you, in your movies, a lot of the time, it seems it's cool because you seem very optimistic about it, whereas in your movies, it's very pessimistic.
My own personal view
more.
is quite positive.
Yeah.
Yeah. I mean, I think it's exciting. I think it's it allows us to engage in the creative impulse of this
It's
earth.
a creative process,
Yeah.
too. I mean, and it's part of an evolutionary process, which is kind of creative.
Yeah, and it's it seems to be what we do as human beings. I mean, we've never accepted the world as it was given to us.
We've done everything else, so now it's going to be us that we have to actually
be us.
alter.
I have to say, I was surprised by how positive David is about our relationship with technology. It was nice to hear. David's ideas about biology as technology got me thinking differently about the interface between humans and machines. I mean, if we are machines, as David suggests, then won't our ultimate transformation come when we can retool our very bodies from deep inside at a biological, kind of organic level? Now, is this even possible? Inspired by David Cronenberg's ideas about biology as technology, I'm going to visit George Church at the Harvard Medical School. George was one of the key scientists involved in sequencing the human genome. Now he's making breakthroughs that will soon let us rewrite it.
The New York World's Fair in 64-ish, they had a vision of the future that they completely instantiated, and you could walk through it, and you could like draw on a little pad a picture, and then it would print out a fabric. There was a repeating motif in the picture. Yeah,
awesome.
You could do that.
Why don't we have that now?
Exactly, and they had people with like rocket thrusters.
Absolutely, jetpacks.
And in fact, since the future didn't arrive, I had seen it. I always felt like it should have arrived, and so I spent a fair amount of my enthusiasm trying to recreate the lost world,
That's
of
amazing.
New York
Absolutely.
in '64. And so my lab kind of pushes the envelope in trying to recreate the parts of science fiction we think we can tackle.
George is among an elite group of scientists working with CRISPR, a breakthrough technology for editing our genetic code. With CRISPR, these scientists may one day make it possible for us to radically transform ourselves biologically.
You might be able to change the brain in such a way that it interfaces better with other brains, with other backup devices.
So you could connect brain to brain, you're saying?
Brain to brain, yeah.
And then have sort of 5 people connected brain-wise.
Or you might fit the entire internet onto DNA and then put the DNA into your brain and have an input-output device. So you're literally carrying around the whole internet in your head.
So
I mean, this is very speculative,
all
but the
of
point...
Shakespeare in my head, potentially.
Well, all of everything in your head.
Yeah, I'm just talking about Shakespeare.
Yeah.
CRISPR is a naturally occurring enzyme that scientists can reprogram and inject into our cells. It will find one of over 20,000 genes and cut it out. It can also add a new one if you wanted to. As George explained it to me, it's kind of like a microscopic, programmable, organic nanoroboot.
And so the CRISPR has the sensor, which is this little piece of RNA you programmed into it that keeps trying until it gets a hit. And then it has a computer that says, is that a good enough match? And then it has an actuator, which is a knife that comes down, machete the DNA, right? So it really is a little robot. It has the 3 basic components, a sensor, computing, and actuator.
Fascinating.
So that one's a naturally occurring robot. We've hardly changed it. We've made it a little more precise.
It's a naturally occurring robot. In other words,
it's a machine that we got out of bacteria. It was discovered in 1987 as just some kind of stuff in the genome that looked like junk. And then as you study it more and more, you realize this isn't junk. This is like the greatest gift ever. It's like you know, like an alien race dumped their lander in your backyard, and you just go in there and you're kind of rooting around
There
for
it is,
cool
and
stuff.
I found-
And here's CRISPR.
And we have these things, but they're found elsewhere in nature. They're not found in us, are they? But you're putting them in
They
us.
are now. Yeah,
right,
they are
exactly.
now.
So that's a kind of cybernetic thing you're doing to us. You're putting, but they're naturally occurring robots.
When we put a knife in our hands, that's augmentation, but it's blunt. But if we can change every atom and we get better and better at knowing how to do that intelligently, then that really starts becoming limitless.
Limitless? That sounds exciting, but it's also kind of scary. Shouldn't we just let nature manage evolution, like it always has?
Did we reach a point where we can't really evolve anymore, and this is what makes us evolve more? Or is it a part of the process of evolution?
Yeah.
Is it just a part of, this is just on a continuum of what it is to be a human being? That
There's no question, we're still evolving. Both our DNA is evolving and our culture is evolving. And now our culture is starting to affect our DNA. And so they're all intertwined.
Right, yeah.
And whether we're, whether we're augmented because of our cell phones and our cars, and whether those are more or less heritable than our DNA, it's like, the fact is each generation inherits all this physics baggage along with the biology baggage.
Right, yeah.
And it just gets more complicated, more interconnected as we go forward. But I think evolution is alive and well.
if you just left us alone, would we like develop wings and stuff like that eventually? I mean, if you just left us alone.
Well, but us is this cultural animal.
Right.
We are being left alone as far as we know.
Right.
Doing some research on my electronic digital brain extension, also known as the Internet, I discovered the term cyborg was coined in a 1960 scientific paper. It describes changes to our bodies that will adapt us for living in outer space. And whether it's a hardened shell-like skin to resist radioactivity or new kinds of bones to survive in prolonged low gravity, George thinks genetic engineering will finally allow us to realize these ideas from over 50 years ago. In fact, George thinks the ultimate survival of our species may very well depend on it.
If we construct a Noah's Ark and get a bunch of us and other species out of the Earth, then that's the ultimate in Darwinian success.
How so?
If an asteroid hits the planet and completely vaporizes, so not even a bacteria lives, that's a fail. That's a Darwinian fail, okay? And if one organism has its act together enough to escape that's a gigantic Darwinian success. Because the real thing is being ready for the unexpected.
I left George thinking a lot about evolution. It seems we transform ourselves and everything around us in order to survive as a species. That we've been extending and augmenting ourselves ever since we fashioned our first rudimentary tools. We have evolved with technology and will continue to do so. It's inseparable from us. So we really are natural-born cyborgs. We always have been and always will be. Of course, I still believe that science and technology can be used in wrong ways and can lead to our dehumanization, but it can also be used in right ways to help us survive and prosper. Now, the most comforting thing to have learned doing this show is that there are scientists like the ones I met with that will be playing such an important role in how we will evolve into the future. They're not only brilliant scientists, they're imaginative, creative, and deep-thinking people. They seem to think a lot about what it is that makes us human and what will someday make us more than human.